Hello, so we are back. But this time, I just want to share with you a case I have here, and it's quite complicated. Now, this video is not for beginners, okay? It's for the people that are on this business, they are fixing laptops, and maybe you can give me an advice. Where can I find what I'm looking for? So what do we have here? Here we have a nice laptop. It's a Asus Zenbook 13, yeah? i7 10 gen. And I will show you how the future of electronics looks like here, because this is the most advanced power management chip I ever seen. Now the problem with this one, the customer said like that. He restored the Windows, he installed a driver, and the moment he installed a driver, the laptop show on the screen, charger disconnected. And from that point, the laptop wasn't charging anymore. But the laptop was on till the moment the battery drained out. That's what the customer told me, yeah. And you know what? I replied the customer. I say, you know what? It's just a coincidence. Actually, the power input circuit doesn't really have much to do with the drivers. You know what I mean? I mean, you can shut down the laptop and the laptop will still charge. Okay, he sent the laptop here, and obviously the laptop arrived here. The laptop is dead. Let me plug the battery. So what you will check first? Yeah, probably you can check first. Let's say the battery. You can check the battery voltage. You can check that. Let's switch. We have the multimeter on screen. The battery voltage 14.8. Okay, so the battery has voltage current. Now plug in the charger. I'm just trying to explain you the way how I goes. Yeah, maybe you will go on a different way. If you go on a different way, just let me know. Because obviously you have to diagnose a problem and you have no schematics, by the way, yeah? So we have no schematics for this particular laptop. Now on the power meter, you see 5 volts, like 33 milliamps, basically nothing. On the other port is the same. Okay, obviously the laptop is not coming on, nothing. You can press the power button, nothing will happen, nothing it will change here, dead, yeah? The laptop is dead. So what you'll try to fix or what you'll try to do? Well, first you want to assure your I/O chip has voltage, because the PD power management chip, it will speak with the I/O chip. And I did check, and the easy way to check, it's on the keyboard. Just keep in mind we don't have schematic, yeah? So on the keyboard, you see, just checking on random pin, we have 3.2. That means the I/O chip has voltage. Now, obviously, your attention, it will go to the power management chip. The problem is the both ports are doing the same, yeah? And if you check here, and you'll think, okay, that's pretty simple. You have here the power PD controllers. No, these are the retimers, and they are speaking straight to the CPU. So actually this chip is the power delivery controller, okay? So this is a power management chip. Now what chip it is? Now this is becoming interesting, because I believe this is the future on what we will see. So basically, if I will tell you a power management chip actually has a CPU inside and a memory, you'll believe it, because that's what is happening here. So let me show you. Let me switch. Let me switch to desktop, and I'll show you this chip. It's very interesting. I never seen something like that before. Okay, desktop. So pay attention here. What do we have here? USB port C, Type C port controller, yeah? And you can see it has a 32 bits CPU, ARM Cortex CPU, flash, SRAM. So basically, this is a power management chip with a little CPU inside, a microcontroller. You can't believe that? I was like, no way. No way they use a microcontroller inside of a power management chip. Crazy, right? I mean, I've never seen something like that. And if you see the inside of the chip, you have the CPU, the controller. Then you have here USB PD subsystem, where actually you have even the MOSFETs are inside. Everything is inside. Absolutely everything is inside. It's crazy. And the internal schematics. Let's find a simple one. Insane where the technology is going. I mean, you use like a CPU inside of a power management chip. So check here. Yeah, that's our chip. Okay, that's the chip name. So you have the chip here on the schematics. The MOSFETs are outside, but on our case, it's using whatever is inside of the chip. I don't have this part with the outside MOSFETs. I believe I don't have. Not sure because I don't have schematic. But anyway, so this chip is speaking with the USB-C, yeah, 2 ports. Then the chip is speaking with the EC chip. You can see here, EC chip. Then you have that Thunderbolt controller, yeah. So everything, based on this laptop, is you have the CPU, you have the EC chip, you have this chip, yeah, the power management chip, and that's the whole laptop. So we know the EC chip here. We have it's basically a microcontroller. Now we have another microcontroller inside of the power delivery chip, which is crazy. And we have the CPU. So you have to fix this laptop somehow. Obviously, if you check this chip on the board, basically you have nowhere to check. I mean, it's nothing there. Let me show you. So that's our chip. Basically, I check the voltage around. You can't even find like test points to check things like that. Insane, right? Okay. Now the the strange part. You know what? I did spoke with some people on our Discord, and I asked them. I asked the guy which is dealing only with programming the EC, and he said, "Sorry, if you have that chip, he knows about this kind of chips. You should have a BIOS chip around, yeah, like a memory chip." And it is 1 megabit memory chip here. Insane. So this chip is speaking with this memory, and you have here the BIOS chip, which is speaking with the EC chip. Okay, crazy. And now I was thinking, like, okay, so if I have no power here, okay, the EC chip has power, but here is if it's not negotiating the voltage, what can be? Yeah, you fix this laptop. What can be here? Can be an issue with this chip or with your EC chip, right? Because those are microcontrollers. Obviously, the EC chip is harder to be replaced. It's on the other side of the board here. It's on the other side. And I said, you know what? I will get this chip because there's nothing what I can check. What I can do, every communication is digital. There's nothing what I can do. I will replace this chip because it's not speaking with my charger, and it's most likely to be this chip instead of the IO chip. And I will see. Anyway, I check with the thermal camera. It's nothing getting hot, And I did order this chip. I ordered the chip yesterday. Okay. On a point, I said, you know what? Okay, it's not charging. Let me charge the battery. Let's try to simulate like working condition. Let's see what's happening. I did charge the battery, and the laptop came on. I can't believe I seen the lamp flashing, and I seen the BIOS menu on the screen. Yeah, I seen the BIOS menu on the screen, and the battery was like 1%, and the laptop shut down and never start again. On that point, I was thinking, wait, maybe this is not a hardware issue. Maybe it's a software issue. And the guy which I asked him about this, he said, try to rewrite this chip. Yeah, it's 1 megabit. You should find somewhere. Obviously, I can't find this part. I found the BIOS. I reload the BIOS. I rewrite the BIOS, but not this one. Yeah, not this one. And I'm stuck on this part. Anyway, as everything point to a software issue. Yeah, like the laptop came on when I charged the battery. Everything point to a software issue. Yeah, and I said, you know what? Let me check. Let me check some things. And first, what you can check. So, what will happen on a laptop, like on the new ones, on the new laptops? Basically, what you can check? You can check something related with the BIOS voltage. So usually the BIOS doesn't have voltage, right? A pin number 8, and you have nothing. But something interesting happening when you plug the battery, because when you plug the battery, you did a BIOS reset, yeah? So the EC chip empty itself. Now, when you plug the battery, either the EC chip, it will load the BIOS, or if the EC chip is programmed from before, it will check the BIOS from inside with this one, yeah? So when you plug the battery, you should have voltage on the BIOS chip, yeah, right? So check on the screen, we have 3.3. For a few seconds till the EC chip is finishing reading the BIOS chip, and it's going to 0. And also when you power up the laptop, you should have 3.3 on the BIOS chip, which is, yeah, should be voltage there. Now let's power up the laptop together. The voltage is right. Here we have like over 14 volts on the battery, right? Yeah, we have 14.8, which is fine. The battery has like 15.4. Now I'll hold on the pin number 8, yeah, there where it was 3.3 before, pressing the power button, check on the screen, 0.4 volts. Yeah, just wait. Wait, 0. So this is telling me a lot. Yeah, it's telling me the IO chip is alive. Not only it's alive, but the IO chip is reading the power button and is trying to start the board. Yeah. Now the problem is 0.4 volts here doesn't look right. Yeah, I mean, if you fix laptops, because I'm sure here people are good people, they are fixing laptops. So let me ask you, if you've seen 0.4 when you press the power button on the BIOS chip, most likely, you know, the BIOS chip, this 3.3 actually is going probably to the PCH. And you will say, like the people said on this morning on Discord, sorry, don't bother to fix this laptop. You know, if you have an issue with this power supply, most likely the PCH is dead. But like how I said, I seen this laptop alive, so that's weird. So I mean, how is possible? I seen the laptop working, but now when I press the power button, I get 0.4. Strange, right? Okay. Which is the power supply of this chip? The power supply of this chip is this one, yeah? So I can check with the beeping. Yeah, beeping. So from here to here is beeping, yeah? So clearly, this is the 3.3 volts power supply, yeah? Also, what is interesting with this power supply is generating the 3.3 LDO, yeah? Low power supply. 1 second, microscope. Yes, so that's my chip. Now let's check. This is interesting. So this chip has 2 power supplies inside. One, which is always 3.3, it's always on, yeah? This one, low power. So if you check on the screen, you can't check, sorry, 1 second. If you check on the screen, so check there, 3.2 volts, you can see. So this is always present, yeah? So this is always present, and what is supposed to happen, when I push the power button, this big one should be 3.3 to give me 3.3 on the BIOS chip. But if this power supply is not working, yeah, because I have 0.4, why I have 3.3 volts when I plug the battery. You know, that's what is insane. I mean, I will unplug the battery, I'll plug the battery back, and let's check together. From here to the coil, yeah, 3.3. How you can explain that? You see, this is what I call a tricky fault. Now it's going to 0, and one more time, if I press the power button on the same coil, yeah, on the same coil, pressing the power button, and I have 0.4. I mean, what you will think? What you will think? You see, this is a tricky fault, and if you don't have schematic, you can cry here. I mean, I spent few hours trying to diagnose this. Okay, it's nothing really helpful. I mean, one time it's working, the other time it's not working. Thermal camera can point you on the right direction. And indeed, can, yeah? So let's check together. Let's check together. Interesting fault. I mean, electronic is interesting. And you see, this detective work, and especially when you don't have schematics and you try to figure it out, but everything seems like doesn't have sense. And this doesn't have sense. I mean, I have 3.3, and when I press the power button, I have 0.4. Doesn't make sense. Yeah. Thermal camera is good. Yeah, let's have a look together. So on the thermal camera, yeah, I will unplug the battery and I'll plug it back, yeah, just to see, you know, what's going on. When I plug the battery, I get 3.3, the power supply, it's working, it's not working, what is happening here? So plugging the battery, and check there, you can see that chip, look, that one, which is getting warm. Yeah, that one. This one, the small black thingy, yeah, that one. Now that one is getting hot when I plug the battery, yeah? It's not hot, it's warm when I plug the battery, okay? But when I press the power button, so let's check together. When I press the power button, so check there when I press the power button, check that chip. This one, matte hot. The one from the power supply, which is taking us 0.4 volts. So what do we know till now? We know this chip is getting warm when I plug the battery. And this chip is getting warm when I press the power button. So when I plug the battery, this chip is getting warm, like it's working, and I have 3.3. Then when I press the power button, this chip is getting proper warm, and I get 0.4 volts. Okay, so the next in line is, and I did check, indeed, this chip is dealing with 3.3, and I said, you know what, the 3.3 on the first stage, when I plug the battery, is provided by this chip. After the I/O chip loaded the BIOS and I press the power button, this power supply is starting, the chip is getting hot, and I have only 0.4 volts there. What you will think? Okay, what you can do more? You can come with 3.3 with the power supply. That's something what we can do, just to check. Maybe it's a short, I don't know. But it's not short because we do have 3.3 here when we plug the battery. So keeping the 3.3 is taking 200 milliamps, you can see there. And the chip, check there the chip. You can see the chip is getting matte hot. Yeah, so it's taking current, and the chip is getting hot. So what is the problem? I'm asking you now. Yeah, if you fix laptops and usually you are dealing with these kind of problems, what is the issue? The chip. This chip, right? Okay. I didn't know what chip it is, and I asked on Discord in this morning. But before I ask about what chip is, I try to do some things. Anyway, I found the chip. Let's have a look at the chip. Yeah, because this is proper interesting, and I want to thank you, the people who helped me on the morning with this chip. because I couldn't find it. Okay, this chip is a SW82A6B. Okay. Now this is the chip schematic. I mean, I can't see how the schematic can help us on this moment, but it's not much what can help you from here. I mean, you have a power supply. Yeah, it's a chip. You have input, you have output, and also you have LDO. LDO, which is always on. A power supply which is always on, the 3.3, which indeed is working. Yeah. So what is not working on my chip? On my chip is not working this part. Yeah. So this part, the high power part, yeah, is not working. This one is working, the LDO, but not this one. And you can see the chip has a DC-DC 3.3 fixed output up to 6 amps, and also has a LDO 3 volts 100 milliamps. Okay, it's pretty simple when you have schematic, obviously, when you have the data sheet. Because like how I said, someone gave me on Discord. Actually, if you search on Google for this, you'll not find it. And also, if you check the Google for what is saying on the chip, you're not gonna find it. But that's why the Discord is beautiful. Okay, good. And here you have the chip schematic. So initially, what I thought, you know what? Let me disconnect the power good, because the power good is 0. And what 0 means? You see, the power good, it's an open drain output pin, and the pin is externally pulled high when the output voltage is 80 to 120 regulation, blah, blah, blah. Okay? So otherwise, this pin is internally pulled low. Yeah. So if you have any issue with this power supply, or the power supply is off, the power good pin, it will be 0, and it is 0 on our case. And I said, you know what? let me show you something. Let me show you the schematic. Yes. So the power good pin is, where is it? This one. Yeah, the power good pin. So you see, it's pulled out. It's pulled out with a resistor by the power supply output. You can see. So same name here, same name here. So this resistor is connected here. Okay, so if this power supply doesn't work, this pin, it will be 0, which it is on my case. So what I did next I said, you know what? Let me disconnect the pin, because if I disconnect the pin, I can simulate a working power supply. I can come with my power supply, I can generate 3.3, and the laptop should start, right? So what I did was, you can see there, pin number 9. Yeah, so I disconnect the pin number 9. Yeah, this one. Basically, I cut the track. Obviously, I rebuild them now, but that's how I checked. So I disconnect the pin. What will happen with the pin? The pin, it will be to 3.3 if the output is 3.3. Yeah, because that's what I did. I come with the power supply here, 3.3 volts, and I simulate a power good signal. Well, it didn't work. Yeah, so I'm just telling you, it didn't work. It didn't work. It didn't work. So it's happened the same. Nothing changed. I mean, the laptop still didn't come on. Okay, so what do I check the next? Because now I have the schematic, obviously, of the chip. The next what I checked was the you have 2 enable pins here. You can see you have 2 enable pins. You have one for the LDO and one for the big power supply. Now this is interesting, and I'll show you why it's interesting. Because I checked the signal, the enable, and it's 0. How the enable signal can be 0? I will tell you what is the enable signal. Enable signal is pin number 12. Yeah, pin number 12. Now, pin number 12 is the enable signal. But you know what? You know what is interesting? Let me focus this. Not this one, not this one, not this one. Where is my chip? Here. Yeah. You know what is interesting? But I seen that later. I seen it later. So let me get this straight. Just to understand how tricky it's a job like this. Yeah. Pin number 12 is this one here. You see, I have a capacitor and you have a resistor on the serial mode. Okay. Probably it's going to the I/O chip or something which is supposed to start this chip. Good. So what is our power on? Look, I will unplug the battery first. Let me show you with the battery. Yeah, I unplug the battery, plug the battery back. Check on the screen. Check on the screen. You have 3.3 volts. So the enable pin is 3.3, which doesn't make sense. I mean, it's 3.3. But now when I start, let me start the laptop. To understand how tricky it is, a job like this. So now I'm on the same point, yeah? Now I'm on the same point, pressing the power button. So I get 0.4. Yeah, I get 0.4 on the output, but nothing here, 0 volts. So the enable signal is missing, but you are still getting 0.4 on the output of this coil. You see how crazy it is? Now, what you will think? What you can do to simulate this power supply. Yeah, so I said, you know what? I said, you know what? I will hold the probe here, yeah? And I will come with the power supply, yeah? I will come with the power supply, 3.3, and I'll try to simulate the enable signal, yeah? So here is the output, and I will come exactly on same point because I know exactly where it is. It's on the other side of the ground. Check on the screen, yeah, 3.3. And this 3.3 is not from my power supply because this is taking zero current, yeah. So this is the enable pin. So if I enable that power supply, actually the chip is working, yeah. So basically the 0.4 volts is coming from somewhere else, probably from the LDO. Just to understand how crazy a fault like this it is. Now, this was the moment when I realized, this was the moment when I realized, okay, so my enable pin, it doesn't work. Because the I/O chip, it is coming when it's reading the power button, it's trying to start the board, but it's not enabling this power supply. And you'll think, sorry, probably this is shorted somewhere, right? Can be shorted because it's the I/O chip is enabling many power supplies, not only this, when the laptop starts. Or maybe it's coming from, I don't know, a faulty resistor, a faulty something. But usually this pin is coming from the I/O chip, keep in mind. Now let's check with the multimeter. Now, same pin, let's see together. Just to understand why I go to the conclusion, I took the conclusion what I will tell you next, yeah? So we have the multimeter, so check here, yeah? So you see the enable is coming here, yeah? But here, before the resistor, I have 66 ohms. Anyway, this is a low ohm resistor, yeah? Yeah, it's a 0 ohms resistor. So compared to ground, I have 66 ohms, yeah? 66. What you'll think, sorry, this input, this enable pin is shorted, right? Wrong. Let me unplug the battery, and let's check the pin together again. And you can see, if I check the pin again, it doesn't show me 66 ohms. That means this track is pulled down by a semiconductor, which is most likely inside of the I/O chip. So basically, what is the problem? The problem is the software. Okay, so because of the software has an error, doesn't enable this, and it's not about enabling this one, yeah. Because even if I simulate, I don't know, a power good condition, the laptop is still it's not starting. Now, I don't believe it's the BIOS. I rewrite the BIOS few times. I don't believe it's the BIOS. I believe it's actually the problem is with this piece of software because this chip is speaking with the IO chip together. Yeah, and obviously, if this chip doesn't work how it should work, probably the IO chip it will not start. Obviously, we cannot know for sure because not only we don't have schematic, even if you have schematic, if you have schematic and you do what? This is digital communication here. There is no logical way to fix something like that. It's just trying. Okay, let's try to rewrite that one, that one. If it doesn't work, it doesn't work. It's you are not lucky today. Maybe you're on a different job. Maybe next time. But it's not much what you can do. And as you can see, the technology goes on. My thing, I believe, is going on the wrong direction because just because you can do it, that doesn't mean you should do it. You should put a processor inside of the power management chip, which is crazy. Yeah, let's be honest. Now you have another chip working with software which can get corrupted. Like how this happened on the beginning? The customer install a driver, and now I believe the customer. When I seen the power management chip, actually it's a CPU and has a BIOS chip, and I believe the customer. On the beginning, I didn't believe it, and I told him, it's just a coincidence. It's impossible, like the charging to have something to have with the driver. But now I believe it. Now actually I believe because of the driver, this laptop got faulty. Anyway, if you have this laptop, this board, this let me tell you the model number. 1 second. But if you have this laptop and you have that small piece of software, which is I believe 1 megabyte software, but you know what? I'll put on the description the model number. Maybe you have it. Maybe you have, because I believe that piece of software, 1 megabyte, it will fix the problem. But I need exactly for this model. By the way, the IO chip, it's a IT5571 here. And the board, it's the laptop is UX325JA. Maybe you have this. Yeah. So again, I found the BIOS. I reload the BIOS, nothing changed. But this piece of software, 1 megabyte, which is going here, I don't have this. By the way, those are connected together. The power. So pin number 8 with pin number 8, these are together connected. That's why this power supply with 0.4 volts was so tricky and so trivial to see what's going on here. Okay, let me know. Maybe you fixed this before, but like how I said, even if you have schematic, how a schematic can help with something like that. You have a pin which is getting enabled. I mean, this power supply is getting enabled from the EC chip. And EC chip is working with software. And the EC chip, it will not work if the other devices which are connected on a data line are not working, like this chip, like the power management chip, which also has a memory. I mean, yeah, this can be faulty, but I don't believe it. I seen this laptop on. I believe this is some software error or something. But yeah, because the people ask, sorry, but you don't have videos where you don't fix things? Yeah, this one, I can't fix it at the moment. If I will find that piece of software which is going here, maybe I can. Maybe I can, because I believe it's software. I seen it on. I seen it with my own eyes. Okay, so I'll stop now. Just, a short about what I'm doing, what I'm working on, how I'm spending my time. I think I spent a few hours with this just because it's interesting. I mean, I never seen something like that, like power management chip with a CPU inside. Crazy. Okay, so thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.